This is a very interesting question, so I thought I'll make a very quick video on this. We've been given a number line here, like this, something like this, and the points are R, S, T, and we need to find out whether 0 is halfway between R and S. So we need to know whether 0 is here or not. Now, if it is halfway between R and S, you should be able to infer that the value of R and S must be the magnitude, at least must be the same. So for example, this could be 1, this could be -1, okay. This could be -2, this could be 2. But then only will it be equidistant. So what you can say is that R must be equal to -S, or R plus S is equal to 0, whatever. So the magnitude must be the same, but the sign must be different, okay. If you're able to make this inference, then analyzing the statements become really easy. So let's look at the first statement. The first statement is that S is to the right of 0. So here is 0, S is to the right of 0, here is T. But I don't know anything about R, right? Whether R is, say, here, okay, or whether R is here but quite far, or whether R is actually equidistant from S. That's also a possibility. So it could be equidistant, this distance can be same. But since we are getting multiple possibilities, we cannot be sure whether 0 is halfway between R and S or not. So this statement obviously is not sufficient. So if I have you, so you can say you're out of the options A, B, C, D, E, your answer cannot be A, your answer cannot be D. Okay. And now let's look at the next statement. So let me just rub this very quickly. Now let's look at statement 2. In statement 2, it's given that the distance between T and R. Okay, so let's look at statement 2. Here is T, here is R, obviously S is here somewhere. The distance between T and R is the same as the distance between T and minus S. Now, there are two cases which are possible. One case is when S is greater than 0. Let me write it here. Okay, S is positive. So if S is positive, then minus S will obviously be negative, right? If S is say 3, minus S would be minus 3, right? So it's negative. So when I'm drawing the number line, think in this way. S is positive, T is here, R is here, and I need to make the distance of T and R the same as T and minus S. Now, what did I tell you? What was the kind of, what did we need to find out? We need to find out whether R and S are equidistant or not. Now, when they're equidistant, S is same as, the magnitude is the same as R, right? So if this is 2, then this is minus 2, right? So if S is, so I took the, or if S is 3, then R will be minus 3. What I'm trying to say here is that if S is greater than 0, and if S is actually equidistant, if the origin is actually equidistant from R and S, then that means minus S will be the same as R. So minus S would be here only, right? So if it's equidistant, if this is S and minus S is negative, then that means minus S will fall here. Okay, and the condition that the distance between T and R, this distance T and R, is the same as a T and minus S would be true. And this is very important. This is one of the cases that you might end up missing, but this is what we need to find out, that if it is equidistance, S and minus S, minus S would be here and minus S is the same as R. So in this case, the distance of T and R and T and minus S is the same. So that's one way of thinking. But if S is not equidistant, that is also possible, right? Here it's S, T, right? If it is not equidistant, then either S will lie somewhere here, or it will minus S would lie somewhere here, or it will lie somewhere here. And in both these cases, the distance of T and R and T and minus S, notice it's not the same, right? T and minus is here, or if I rub this, if minus T and minus is here, so the distance is changing. So when S is greater than 0, the only possible case where it is equidistant is this, but there are other cases where it is not it is not satisfying the condition. So you can say if S is greater than 0, then it will definitely be equidistant, okay? But there's the possibility that S is less than 0 also. There could be a possibility like this, where S is here, okay? T is here, R is here, right? So, and if S is negative, then minus S must be positive. And in this case, if this is negative, then obviously r is also negative. Here, this distance and this distance is same. And if s and r are both negative, then that means the point 0 lies somewhere here or maybe here, but that does not matter. The point is that we need to find out whether it is halfway or not, and we can be sure that 0 is not halfway between r. It is not definitely here. 0 is not here, that's for sure. Okay, so understand this very carefully, that when I'm saying the distance between t and r is the same as between d and minus s, then that means there are two possible cases. In the first case, when s is greater than 0, it is possible that it is equidistant. But if s is less than 0, then it is not equidistant. Okay, so once again, you are getting two different results. And since you're getting two different results, you can be sure that statement 2 is also insufficient. So your answer cannot be B also. It has to be either C or E. Now let me combine and see whether we can figure out whether s is greater than 0 or less than 0. Now, from statement 1, we know s is to the right of 0. Okay. Now, when s is to the right of 0, we know that s is positive. And we saw that when s is positive, then in that case, this holds true. The condition that 0 lies between r and s. That is why, combining both these statements, we can say that the correct answer is C and not E. Okay, so this question can be solved very easily if you're able to visualize it, and you don't need to actually write down any equation as such. You need to just consider all the different possibilities, draw it, and mark the answer.